Hello, I'm back, and this is a talk that I'm planning to give at a local college nearby where I live in Virginia. Um, it's called "Making a Game with No Engine." It's easier than you think, and already this is a bit of a misnomer because if you've been watching any of my other videos, you know that um, I do have an engine. It's just that it's my own game engine. And so, actually, what this talk is really about is making a game with your own game engine that you spend some amount of time developing. And perhaps some of the talk also calls into question the very idea of using an engine. What does that really mean? But it's more geared at an audience of, say, freshman or junior computer science students who perhaps have maybe a year or so of calculus or other kinds of little bit of programming knowledge to perhaps give them a bit of an alternate viewpoint on how some of this stuff is done, to maybe provide just a different way of looking at it that's not super common. So this is also I say this is a collaboration between myself and Midjourney AI. If you don't know what Midjourney AI is, it is an artificial intelligence that generates images based on a text prompt. So expect some of that. So to begin, um, I I chose this prompt. This image is actually generated from a prompt that I gave Midjourney, which is a confused game programmer walking through a labyrinth of complicated abstractions. So this is probably what most of you would feel like if you download something like Unity, or you download something like Godot, or you download something like Unreal Engine. I personally can't say that I've necessarily tried all of these out. I've tried a few out. I've made some small game prototypes with Unity, and I've made some. I think I've played around a little bit with Godot, played around a little bit with Game Maker, a bunch of other of these. And the impression that I got from my experience with these tools, Unity, I spent maybe a little more time in it. I spent about a year playing around with that. Is there's all this stuff, and it exists at a fairly high level, and you don't necessarily understand how any of it works. And so the experience of say, making games with Unity is I have my game objects, I put them in the world, and then I kind of program my game by like attaching scripts to the objects. And so already that's this kind of world where the code sort of exists in these like little isolated pockets, these little isolated islands, and they're scripts. So you don't ever necessarily have this holistic understanding of how the entire game works end to end. So if I go and I start a Unity project, I don't really have, say, and I'm contrasting this with making just a regular program, I don't necessarily have a solid entry point or a solid understanding of exactly where I'm beginning, where that game begins, and exactly all of the stuff that it does. I don't really understand the build process. The build process isn't super transparent. I just trust that Unity's build process is gonna kick out a game program that I can use at the very end. But I don't really have a solid grip or understanding of what are the real explicit steps that are happening in sequential order um, in the course of making that game, right? And my code is these little islands of scripts attached to game objects. And I don't really have a solid sense of what a game object is, right? There are game objects. They live in some kind of world. Um, there's actions that happen on them. You can kind of like update them, right? So there's little bits of code that gets called. A little update function happens, and then some state for a game object is changed, right? And I manage most of that with these little scripts in this kind of object-oriented language. That was my experience with it. So to me, it felt like this big tool chest that I didn't necessarily understand. And so I would come at it with these different questions. So I would come at it with, a question like, okay, I want to use this to make, say, a two-dimensional game. Okay, well, that's odd because the first thing that I get thrown into is sort of a 3D kind of a uh, scene setup. And so already I don't have a sense of what, because 2D games are fundamentally different from 3D games. And so what is strange to me is, in trying to do something like that in Unity, is I have to then um, try to try to like sort of graft 2D games onto a 3D thing. And I don't necessarily understand why I'm doing that, or what that's about. And I, working at that high of a level, because you don't have this holistic understanding, it just leads to all kinds of confusion about what's really going on. And so that's kind of how I characterize most of modern game development, or most of game development using these engines. Is you're in this labyrinth. You're kind of like this headless guy. You're like, what does this do? What does that do? I don't really understand all these pieces and how they work together. And so I didn't find this very particularly satisfying. I wanted, I guess, a better answer. I at least wanted to understand how all of this stuff works. And so that led me to making my own game engine, which, of course, much of what you've probably been taught about that is that, to do that kind of thing, you need to be like this guy, right? So this is another prompt that I put in. Very intelligent programmer, always knows the right math, algorithms, and data structures to do the job perfectly. Obviously, this person is much older. He's already kind of starting to bald. He's got that very smug, sort of arrogant look. That kind of I know what's right for you. I'm gonna tell you about all these perfect abstractions, and I'm sort of looks like one of those master of the universe types of people. You might think that that's what you need to be in order to make a game engine. I am going to tell you that that's not really what it's like. It's more like just sitting down and doing the work. It is a reasonable amount of work. But you don't necessarily need to use the most advanced algorithms or the most advanced abstractions, or become an expert in high level programming, or data structures or algorithms or any of that stuff to start making games. And that is with your own engine, actually. So given the knowledge that you audience has presently with your amount of programming skills, you could start today and you could build towards having your own game engine, having your own studio, all that stuff, just with some fairly basic math, some fairly basic algorithms. Obviously, you'll go a little bit further if you have a more clear understanding of how some of these other things work, and I would encourage that. I would absolutely encourage spending more time with data structures and algorithms and that kind of stuff. But if all you really needed, to do was make some game prototypes, you could do most of your job with just, arrays and basic functions and that kind of thing. So you don't really need to be like this guy to make games. So this would lead to the most common objection that I would say I get to making your own game engine, which is something of the flavor of, that's great and all, but we need to be productive. We need to kick out fast prototypes. We need to iterate and find the fun. Oh my God, you're gonna be dead by the time you ever ship a game. You're gonna be like this guy. That actually is the image that was generated from that prompt. And what I love about this Midjourney is how it translates the sadness of your crushed dreams into this. This image of this, it's this old guy, and there's this gray dust coming from his hair, and of course, not only are his dreams shattered, but literally the computer monitor in front of him is shattered, and it's just all lost hope because he didn't use Unity, right? And what I'm going to tell you is it's actually not like this. Yes, the first few years and the first few months of learning, say, a lower level language like C, something that gives you more access to memory, is perhaps it's going to be new, and there's going to be some struggles for sure, absolutely, but nothing that you can't handle, and nothing that by the time you get something going, you're not going to be like this guy. You'll probably be like, if you start early, well, then you'll be even younger when you do something like this. But I spent it took me maybe a few years just in my spare time to kind of wrap my head around some of the basics. And then I had a fairly decent 2D game engine I could use. So I'm still relatively young, roughly like middle aged. I don't see my dreams being totally crushed. And now actually I feel like I've got a pretty productive way of working. Most importantly, I feel like I have a sustainable way of working that actually makes me happy. And so that is what I always wanted. So what I'm here to tell you is, you may have heard that it's like this. It's not like this. So how do we prevent ourselves then from becoming just totally overwhelmed with an avalanche of work like this guy? Right? We've decided to make a game engine. That presumably is hard. That presumably is something that does require work. And that's not totally a lie. But the thing that they don't tell you is there's oftentimes a conflation that happens between the idea of making a specific game for a specific audience versus making a general purpose game engine tool that could be used by a lot of different people to make a lot of different kinds of games. Those are two very different kinds of projects inherently. If my aim is to just make a specific game, say I want to make a platformer, a 2D platformer, well, that automatically rules out all kinds of stuff, right? I've automatically ruled out 3D, so I don't have to do 3D. I've automatically ruled out a bunch of stuff having to do with, say, pathfinding, right? Probably don't need that. Probably just need some simple physics, some simple collision detection logic, right? I've probably eliminated a bunch of stuff about how to draw the textures for the characters, right? So if I'm doing it pixel art, then I've got like one shader that I'm probably going to use, and that's going to be the majority of it. I've probably eliminated a bunch of fancy logic about loading levels and that kind of stuff if I've chosen to do like level-based gameplay. So the more that you what I'm trying to get at is the more that you hone in on your product and really understand exactly what it is that you're trying to make, then you can sort of start to do these Occam's razor kinds of things where you just cleave off massive amounts of work that you shouldn't be doing. So the real task of an independent game developer, I would argue, is to get very close to understanding what your game is about. And the closer that you get to that understanding of what your game is about, the better you're going to be at not doing work you shouldn't be doing, right? It's not overwhelming yourself. The exact opposite, the thing that, of course, nobody should do is make a general purpose game engine first and then make a game, right? That's obviously not a great idea. So by definition, this work process that I've come up with, well, I haven't really come up with it, but this work process that I use is very heavily focused on making prototypes, low fidelity prototypes that I then kind of polish and then kind of gradually turn into something that I understand a little bit better and a little bit better and a little bit better. And I'm making decisions that prevent me from doing a bunch of unnecessary work. So we don't want to be like this person or this like little speck there, I guess. And I love how I guess that's like that edge thing is like the computer screen, right? So it's like this like wall of like just this avalanche of work comes flowing through your computer monitor and you just get buried in it. Yeah, we're not making a general purpose game engine. So, when you hear these arguments like, oh, well, Unity's got hundreds of engineers, you couldn't possibly do the work of hundreds of engineers. Well, okay, wait a second. Yeah, they need hundreds of engineers because they're making a general purpose game engine. You are not, right? So again, like that's a logical fallacy, right? Of course, if the nature of the project is such that by definition, because it's general purpose, it requires more laborers. You can't then compare that labor force required for that product with the labor force that would be required for something that is going to be doing a much smaller slice of work. So be aware of the kinds of things that people say and really kind of step through their logic there, and I would say question it. So this kind of leads me to my next point is back when I was younger in say like the 90s, it was pretty common for people just made games. I didn't really hear much of the talk of game engines, right? They're and if you do a Google Ngram search of this right now, you can search for the term game engine, and it's kind of used a little bit in the 90s, so maybe people are starting to have more of an idea of this sense that there's this like base framework or base set of tools that's required to make a game, this kind of like game substrate, we could call it. But it doesn't really come into popular parlance until the 2000s, right? Until we've got Unity, till we've got Unreal, till 3D graphics are more of a thing, and until people kept taking on bigger and bigger, more ambitious projects that would have required perhaps a more robust starting point. So that's just something to keep in mind. For a good portion of the history of video games and their existence, even to today, I would argue, we just made games. And I kind of like that rather naive sort of mindset, right? I'm not trying to, prove some theorem about game development in some ideal abstract mathematical universe. I'm just trying to make this game about Moose, right? Like that's actually what I'm up to here. I'm making this game. So, by the way, I'm actually stunned by this particular creation from Midjourney. I cannot believe that it came up with this. I just gave it the prompt Moose pixel art, and I love how it kind of figured out the style, although not perfectly. This is a beautiful work of art, and I gave it a text prompt. And actually, a human being could take this and turn it into some kind of pixel art masterpiece. So I am thoroughly impressed. What I'm going to show you now is my game. So I made a game with my game engine. I believe in, shall we say, practicing what you preach. So I'm not going to go and do this and then like not make a game. So this is my game. It's called Mooselutions. And it is a puzzle game about angering moose. So I've got about, 40 levels-ish. I play this lumberjack. And you see how the moose kind of have like the moose kind of can spot you. So if I go in front of a moose and I make him mad, then he will charge on the next movement. So right now I've just angered him, but when I move, he's going to charge, right? And so I've got this other moose right here in front of me. And if I step in front of him, then he's going to charge, right? You kind of go through all these iterations of levels. So it kind of builds on itself like any other sort of puzzle game that you might have played. This is very much like Baba Is You, Steven Sausage Roll, A Monster's Expedition, that kind of thing. So here's a kind of like moose problem. I have this moose. If I step into his detection zone and anger him, then you'll notice that he blocks my exit. So I can't walk over a moose just like it would happen in the forest. So we need something better. This game also has the ability, if I press R, I can totally reset the puzzle. So that's an option. So if I anger this moose, right, he charges in front of the other one and kind of stops him from being able to detect me. So a moose in front of a moose stops the moose from seeing you, and then you can kind of go forward, right? And so it just kind of builds. This is sort of teaching this idea of if you hit a moose from behind, it's going to make him charge, right? And so we kind of keep going, and layering the complexity on here. So this is what happens. I've introduced. I'll show you a little more, bit more of an advanced puzzle. So this is like maybe a little bit further in the game after we've kind of introduced a few different ideas. The game has a pushable little brick stack. So this is like just a block, kind of like what you would see in, say, the original Sokoban game. And I can push my little brick stack in front of the moose, and he will he can't detect me now. So I'm not gonna anger him, right? Well, okay, great. So you see this moose up here, right? I need to get this moose down here, or I've got these two switches here. So this rock isn't moving until I activate all the switches. So I need something on this, something on this, something on this, something on this. The block works, but remember, you only have one of those. And so that thing, it can move more or less freely, but since you only have one, there's some limitations there. So maybe what I might try and do is get him to go here, right? And then maybe what I would do is I would get him to go here, and then I could get him to go here, right? Oh, and now I can just move my block onto this one, right? You would think. So why don't I do that? Oh, except, of course, if I step in front of a moose, so me trying to move my block out of the way is going to anger the moose that's on that switch, which means that now I'm kind of in this state where I can't solve the puzzle because this moose is like all the way over here and I need something here and I can't ever get him to move, right? So actually, it turns out that the solution to this is a little bit more nuanced. So instead of just doing kind of the naive, bumbling solution, what I want to do is I want to get this guy mad and charge him in front of there, so that now I have essentially freed up my block. I can move my block without angering this guy over here, right? And then what I can do is I can go around the back of this guy, and then I can anger this guy, right? And get him to. So when a moose hits another moose from the side, it'll rotate the moose in the direction of impact. So now I anger this moose, right? And he charges up to this block. Now this block, I would argue, it's almost like chess. Like this block is kind of in a state of check, right? Because this moose, if I move this block, this moose is going to get mad. So I need to find a way to free this block, right? And so the way that I can do that is I can anger this moose and get him to charge into that moose. And now my block is free because if I move it, I'm not going to anger any moose because this guy has his peepers on this one over here. So I can move around, right? And then I can just place my block here, right? And then that guy, and then that guy goes, and then that guy goes, and I've solved my puzzle. So that's just one example of the kinds of puzzles that are in Mooselutions. And the idea is just kind of me playing around with a lot of the systems and sort of noticing the kinds of things that you can do and the sorts of interactions that are possible, and then kind of building puzzles out of what's natural to this world. This isn't really a talk about game design per se, although what I will say is the more that you spend your time in the design space, in the space of really understanding what your game design is about, that is what enables you to focus more clearly on what to do and what not to do. So the more that I understand that this is a puzzle game, I'm focused on puzzles. I'm not focused on action mechanics. I'm not focused on, there's a bunch of stuff that I'm not doing. And this is a puzzle game. It's specifically about the moose. So I'm not going to make levels. I'm not going to make any levels that don't have moose in it. This is Mooselutions. This is what this game is about. If a puzzle doesn't have a moose, it's not Mooselutions, right? So every puzzle has moose in it. And the moose are kind of that central focal point of the game. It's about the moose. So that really helps you focus what you're making, so that you don't spend hours and hours and hours making some general purpose game engine or some general purpose game or some kind of thing that ultimately isn't going to really help you get your thing to market. So where I think a lot of the productivity problems people have, I think they come from just not spending that time really trying to understand what your thing is about. Okay, so enough of that. I want to show you some other features that this game has. So I say game and game engine, and part of that's kind of true because in order to make the game, you do need this sort of scaffolding. So one feature that I've kind of hidden in here is if I press the E button, I'm now in edit mode. And so what I essentially have here is a game that is its own level editor. And so if I press space, now this guy moves. And if I hit E, now I'm back in the game, right? And so I've just changed where that player goes. If I hit E again, I have all these different menu options. So I can, let's say that I wanted to place the moose in a different location. So I can take this moose. If I hit D when I'm on a moose, I get rid of him. If I hit space, I move him. If I hit R, I rotate the moose. And so I can move my moose. That's something I can do. Anything that has any kind of impact on gameplay that's in here is something that can be used. So I've got this like cracked block, right? And I've got this pile of bricks. I can move the pile of bricks. I can add as many piles of bricks as I want. I can also I can move the goalpost. I can put switches anywhere, right? And if I hit E, I'm immediately back in the game, right? And I'm immediately just playing the game as normal. And so I can swap in and out of these things. And as soon as I'm ready to save, I can save the level. I can open another level. If I am in the game and I hit enter, I can go into the level select menu and I can just go back to another level that I've been playing around with. The whole idea here is to create a very cohesive set of tools that allow you to just very quickly iterate on your ideas, very quickly try out different puzzles, play around with something, move something around, and instead of having to recompile the game and rebuild a bunch of stuff, you're just thrown right into it. So it's this idea of I'm kind of rapidly iterating on my game idea, rapidly figuring out what's working and what's not working within my own set of tools. I'm making all these puzzles and playing with it and trying it out. And eventually what happens is by the time you've done this process over and over and over again, as I have, I'm up to like 39 levels, and most of them, they start to get fairly sophisticated after a while. But they're this process of kind of trying something out and curating and kind of boiling it down until you get to these essential, like really, really good puzzles. So the tools, the level editor is just built right into the game. And what makes that possible is the fact that I chose to do my own quote unquote game engine instead of using a commercial based engine, because I have more direct control of memory. I can tell my game what stuff to load in and out. I can program in these custom modes like a level editor mode, and I can program in the ability to just swap between the two. And then I can also change my game's build process to not include the level editor if it's a release build of the game, and then to include the level editor if it's not a release build of the game. So I have all this kind of flexibility just baked into the whole thing. And I'm not here to argue that you wouldn't be able to get that with other game engines. I think you probably can. But what I am here to say is that it's you might find yourself fighting with their systems in order to do that, because they're going to have an opinion about how all this stuff is done, and that opinion might not necessarily agree with your opinion. And so if you can sort of undercut these software development kits, these game engines, and go one level below them, then you have all this amazing flexibility that not a lot of people really talk about. And so I'm here to talk about some of that stuff and to say, hey, actually, this is pretty cool, and you might find some benefit from it. So that's the game. I can show more of that later. Like I said, I'm just kind of still working on it. A lot of it's there's more polished pieces. If you look at, like, say, first level, we have all these different modes in here. So I didn't show the kind of aesthetics editing mode. So I also have that. So you see, I'm in tree mode, and when you're in tree mode, I've programmed it in so that the trees go on a half step. So that's kind of cool. And then I can put like a faded tree in, or I can do all this kind of stuff. And I can place the edge tiles and all that stuff. So not only is this tool a level editor for the gameplay, but it is also a level editor that, say, somebody who is very heavily invested in the aesthetics of the game can get into, and they can start placing stuff down, and they could start using it. So it's not just limited to me prototyping this thing. I am actually building this tool so that other people on my team can go in and start to make the levels have a certain kind of look and feel and charm to them, because that's also a very big part of games. So that's Mooselutions. We'll return to the rest of the talk. Okay, so another interesting thing that you might not know is Mooselutions is actually the product of a game jam. So I made Mooselutions. Oops. I made Mooselutions during a game jam about a year ago. Me and some friends did the low res game jam. It was a 2-week thing, and it involved the initial prototype could only have 64 pixels by 64 pixels for a canvas size, and that meant some pretty hard constraints. The original graphics are very low resolution, very, very few pixels there. I don't have an older version to show right now, but if you go on itch.io and you look for Mooselutions, you'll see the older version. It's doesn't look great, but the important thing about it is that that even that much older version already had the core ideas of the gameplay in it. So I think the ultimate test of whether or not this way of doing things is a good idea, this sort of productivity thing that I've figured out, or this way of working on games, the best way to test it is to say, okay, well, can you do a game jam with that? And the answer is yes, with some caveats. So first of all, before you do the game jam, you should probably have some sense of what the game jam's going to be about. In this case, we picked the low-res game jam, and we knew before it started that it was about low-resolution graphics, and it was about having a canvas size constrained to 64 pixels by 64 pixels. Now, if you read some of the rules of some of these game jams, they say engine code is allowed. And so what I take that to mean is you can more or less get the basic substrate of the game engine in place, say 64 by 64 canvas, basic pixel art graphics, that kind of thing. You can get all that stuff in place before the game jam starts. And then when the game jam starts, you should just focus on the kind of core slice of what that game is about. You should just focus on the gameplay. And that's what I did. So before starting that game jam, I spent maybe a week or so just taking my existing engine code and ripping out some of the gameplay specific stuff for one of my games, but keeping in most of the 2D sprite rendering, that kind of stuff. and then changing the canvas size so that was 64 by 64, and just basically setting up a blank canvas so that once the game jam started, we could focus on the gameplay. We could focus on just kind of jamming out that core slice of what that game is. And that's what we did. And we spent 2 weeks on it. I chose this image, or I had Midjourney make this image because, video game design of the fever of a dream, haze of a sleepless night. I came up with this just to show you that this is explicitly what we did not do. So, by the way, this looks like a cool game. It actually kind of looks like Elden Ring or something. I would love to play this game, but this isn't what we made. We did not, for these 2 weeks, we did not stay up and drink Red Bull until all hours of the night. I actually wasn't working at the time, so I just took 2 weeks and treated it like my day job, right? So that's what I did. And we maybe worked a little bit extra, maybe half a day on the weekend or something. I think maybe we did that right before shipping it. But I just want to say that we had a fairly normal work schedule when we worked on this for the game jam. And we were able to do that because we made some smart decisions before the game jam, and also because we had a very smart work style that was focused on prototyping the core idea of what the game is about and not really focusing on all of the other side details. So during the entire game jam, the only thing that I was interested in, the only thing that my artist was interested in, the only thing that our sound designer was interested in was those core elements of the game. Was what's the core gameplay mechanics, right? We've got these moose, they have a detection zone in front of them. You step in the detection zone, they get mad. What do they do next? How do we make it a puzzle game? Well, one way to make it a puzzle game is to have discrete movement. So movement is, tile by tile, etc. We focused on that. And that's all we prototyped. We had about 15 levels, decent puzzles by the time, and none of the more advanced concepts. So there wasn't even any concept of a pushable block or anything like that by the time that jam was done. It was just the basic gameplay for that game. Kind of figuring after the jam, we would then go and make all the more advanced stuff. So we did okay in the game jam. We actually broke one of the rules because we had sub-pixel movement within the 64 by 64 canvas, which is a little bit of splitting hairs. So, but we got 19th in game design. And actually that was my goal for that game jam, was to do well in the game design category, to do well in the concept category, because what I wanted to do was finish the jam and then use that more crystallized thing, or that gameplay prototype, to then as a springboard to make a full game, right? So that's kind of what it was for. So it's just to give you the sense of, you might think it's not possible to use your own game engine in a game jam, but actually, if with a little bit of thought and consideration, you can totally do it. Very much a good thing to do, and actually that I think is one of the tests for whether or not this kind of thing can work. Is it a good idea, right? So let's assume that I've convinced you. Maybe you're not convinced, but let's assume that I've convinced you that this might be something you would want to do. How would you go about doing it? Are you going to be like this guy? I don't know what those things are on his computer, but maybe those are all the different choices. I also like how the AI was he kind of got this Rust sort of looks like it says Rust on there. But he's frantically figuring out what kind of tools should I use. Well, I'm going to help you with that. Essentially you're going to be given a bunch of different options, and what I want to just suggest is I'm not going to tell you what programming language to use, because that's not really something I'm interested in. I think there are a lot of great choices, but what I will tell you is that there's a certain level of abstraction that you're going to want to program at, and that is the systems level. And so systems level languages would include languages like C, C++, Rust would be considered a systems level language. Um, I think D would also be considered a systems level language. Essentially, what you want is a language that gives you control over memory. Being able to tell the system where things are in memory enables all kinds of efficiencies and allows your game to run fast. In case you haven't guessed it, games need to run fast. Why do they need to run fast? Well, you're literally telling a computer to draw like 60 paintings in a second. That's insane. No human being could do that. It's amazing that we have computers that can do that. But in order to make the frames in a game look smooth and look like something that you would want to play, it needs to draw a lot of frames, like really fast. So that means the core loop of your game needs to run like 60 frames a second, and you need to be utilizing the resources on the CPU as best as you can. So we need to understand what the major bottlenecks are here. It used to be that the major bottleneck in code execution was the individual instructions. And that's still kind of true, but it isn't so much true anymore with some of the new architectures, the new hardware architectures. The newer hardware architectures actually have memory access as the major bottleneck. So it isn't time so much spent on executing your instructions where things get slow. It's actually in asking the CPU to go and get some data from memory. That's the slow part. So if you have a language that gives you control over where things are in memory, then one of the things you can do is you can have it very tightly pack things together in memory so that it doesn't need to go to main memory as much. It can go to main memory and just get that very tightly packed array of stuff, and it can just execute over that really quickly. And if that array is really small and close together, then a good portion of it will fit in the different caches on the CPU. So you've got level 1 cache, level 2 cache, is usually level 3 cache. The more that your CPU can kind of keep the data in the cache, if it's small and tightly packed together, then it can keep accessing the cache instead of having to go to main memory, which is very, very quote unquote expensive. It takes a long time to go to main memory. So I chose this image, or rather I had Midjourney choose this image because it's a good example of, first of all, so this actually was the prompt, was Super Mario limping because the game engine he is running on is slow and was built with an object-oriented mindset. What I love about it is like not only is Mario just kind of like sad and deflated, but like what I love about this AI is it's like it translates the emotions into the surroundings. So like the cloud is sad too, and it's just this terrible kind of game engine world that you would never want to find yourself in. Just depressing. And I said object-oriented mindset because many object-oriented languages, by default, I'm not necessarily saying all of them do, and there are ways to get around this, but many of them by default think that they have memory allocation spread out all over the place. So individual objects or individual pieces of data are allocated on the heap, and they're allocated all over the place in memory. And so there isn't that tightly packed group of stuff in memory. And so when you ask the CPU to go get the stuff that's in your game and operate on it, it's jumping all over the place, which means that the data gets evicted from the cache, and it has to keep your CPU. It keeps getting bottlenecked on memory access. So because you're asking it to jump all over memory. So that's one problem. Also, many object-oriented languages prefer to use garbage collection. And garbage collection imposes a performance penalty as well, because as your game is trying to draw the frame, say in the middle of running your update logic and then figuring out what to draw, the garbage collector gets invoked by your language. Well, that sucks because you're going to take that performance hit. The garbage collector is going to go and deallocate a bunch of stuff, and you're just going to have to deal with that performance hiccup. And so a consequence of garbage collection is a very spiky looking performance graph where it's things aren't really all that smooth, because in the middle of something you'll get this deallocation, or you'll get these unpredictable spikes in resource usage, right? While you're just trying to run your logic. So you want to remove all those unpredictable elements from your system. You want to remove as many of those as you possibly can. And one of those is garbage collection. So we don't want to use garbage collected languages. Now for my game, I chose a kind of C flavored C++. And what that means is I basically used C++ like it's C, and didn't really opt into a lot of the fancy stuff like template metaprogramming and like all the object-oriented stuff. I basically used C++ like it's C. Some people are a little bit more hard line. They only use C. Some people, again, I'm not here to advocate for a specific language. What I am here to do is tell you that you want something that's roughly at the systems level, because that's where you can have the kind of control over memory that allows you to ensure stable, clean, consistent performance. So, great, we know what language we're using. We're using a systems language. What about the data structures? What other stuff are we going to use? I would argue that most of what you can do, if not the majority of what you're going to be doing, is just using arrays. And that is in practice what I use in my games. I just use arrays. So that's because most of the time in the early stages of making a game, you're really just kind of figuring out what the game is, and you're not necessarily having the most optimal performance. So if I'm just kind of playing around with my Moose puzzle game and I'm just trying to figure out what the gameplay is, I might have something that maybe a binary tree would be better, or maybe a hash map would be better, or maybe this other slightly more advanced data structure would be better. But it's going to take some time to implement that properly. And I still haven't figured out yet if I even want to keep that piece of gameplay. So what I would argue the better thing to do is, in that situation, while I'm figuring out what the gameplay is, while I'm figuring out what the game is about, I think it's better to just use, quote unquote, crappy data structure, and just use an array for that, and play around with it, and know that the performance isn't great, and know that if you decide to keep that part of your program, of your game, because maybe it's great but has an impact on performance you don't like, then know that you're going to come back and you're going to make that better later on with a better data structure. So that's most of what I've done. There are some parts of my game where just because I've had to, I do use other types of data structures. But most of it's just arrays. The entire world is actually a two-dimensional array. All of the entities in the game world are just a one-dimensional array. And then I have things that map that one array of entities to a specific location in the tile grid. And so which is essentially just a two-dimensional array. So that's most of what I do. And you'll find that the most important thing that I do, there is one optimization that I make up front. And that is a memory access optimization, which is to say that up front, the game is designed to be cache friendly, which is to say that all of the parts of it that are operated on the most are packed tightly in a small array, so that they're very close to each other in memory. And that there's another word for this. It's called data-oriented design or data-oriented programming. Definitely look it up, worth your time. I make those kinds of optimizations by default because I know that memory usage is the major bottleneck in computing these days. Memory access, rather, is the major bottleneck. So I focus on those optimizations. I make sure those are good from the start. That's the only thing I do from the start. And then the rest is kind of later. The rest is, maybe we'll use some of those other data structures later, but not while we're figuring out what the core gameplay is. So that's the kind of balance that I strike. And what that means is that as long as you have some understanding of memory access and how to lay things out in memory, that's really all you got to focus on. You're not going to be doing very many advanced algorithms or that kind of stuff for the majority of your game development. So something to think about. All right, what about math? Yeah, some games have very advanced math. The most advanced math in most of my games is usually some form of Newtonian physics. So it's, your basic acceleration functions, velocity, position, displacement, that kind of stuff. That's the majority of the math that's in most of my games. Collision detection starts to get a little bit more, especially like real-time collision detection and response. Say if you were making a platformer, that kind of thing can get fairly hairy, like for a 3D platformer with all kinds of special shapes or whatever. But what I would say is that for the majority of what you do, when you're just prototyping something out, when you're just starting, you can actually use fairly basic math, fairly basic shapes. So let's say that you are going to do that collision detection. Well, don't do it with like some fancy, three-dimensional polygon mesh. Do it with just do it with a cube, or do it with a rectangle, right? You don't start with the most advanced case. Start with a basic case, and then kind of work your way up as you play around with your game. So you can get an incredible amount of distance. You can do a lot with fairly little math. And then, later on, as you prototype your game more and more and more and start to work through some of those more specific problems towards the end, then you can kind of come back and say, okay, this is a place where we could really use that pizzazz of this very advanced algorithm. Let's we could really get a lot of juice out of that. Let's invest the time in that. But you don't really need to do that when you're just laying out the structure of your game, just trying to figure out what makes it fun, all that kind of basic stuff. So this leads me to some concluding thoughts about some advice that you may have been given about how to program stuff and how to make things. And it's advice that I very strongly disagree with. And so if this sounds a little bit ranty, my apologies. I've just been exposed to this stuff for way too long and have a very strong opinion about it. But basically, there will be people who will teach you some version of if you just write all these diagrams of make these UML diagrams of all the different kinds of things in your program and their relationships to get to each other, then the program will just write itself. Like just make a class diagram, and a cat inherits from an animal, and an animal inherits from an object, and an employee inherits from a person, and just draw all these diagrams, all these stick and box diagrams, and plan out everything in advance. And then when you sit down to code it, you'll just know exactly what to make, right? Well, wrong. It never turns out that way. Whatever idea that you have in your head that you think it's going to be, it's not going to be. And so I chose this prompt, computer programmer perfectly predicts software architecture ahead of time before writing a single line of code, because this makes it look like it's so easy, but actually that never happens. It never ends up being that way. And the way I've made my games is just by sitting down and doing one thing at a time. So to make Mooselutions, I sat down and I was like, okay, I need a square, a colored square. How do I do that? With say metal, okay? I need to be able to move the colored square around in a two-dimensional coordinate system that has the same size as the screen of my computer. How do I do that? How do I tell it? How do I translate screen coordinates into something that the GPU understands? so that I can move this square around, right? That's something I need to do. Okay, now I need to have my colored square moving thing work on multiple platforms. So in that case, I need some way of separating out the operating system or platform specific logic, the code that runs on a Mac, from the code that runs on a Windows computer. How do I do that? Right? Or I need some way of separating the game state from any specific operating system that it could be running on. How do I do that? So all that a good program is just a collection of solved problems. It's not something that you design completely top down and then just follow your design like these UML diagrams. No, what you're going to do is you're going to recognize that you've got to solve all these problems, and you're going to solve this problem, that problem, the next problem, on and on and on and on and on and on. And once you've just solved all the problems, someday you're going to wake up and you're going to have a game. And that's really how it works. It is very piece by piece, just like that. And so I leave with this last slide because you are going to be exposed to a lot of bad ideas. I think that computer education or computer science education is in a state that is not all too different from the medieval times. I think we're still pre-Enlightenment here. I think we haven't really adopted clear scientific principles for how we make software. So you're going to have a lot of ideologues. You're going to have a lot of people peddling this ideology or that ideology of how to program. Again, I'm here to tell you that I'm not going to tell you what programming language to use. What I am going to tell you is you probably want something that's at the systems level because of this memory thing. And that's based on hard facts. Like these are hard facts about just how a processor works, the physics of it, that are just true. And you can't really argue against ideas that are rooted in the hardware. So I would say be very skeptical of some of these high level ideas that are presented to you, especially if the person that's saying them makes most of their money from speaking engagements or consulting or that kind of thing. That person has a really vested interest in making money off of selling you on those ideas. So those kinds of people, I would also say, if you're looking for somebody that, who should you look up to in this kind of space, I would say look at people who have shipped very difficult projects, right? Look up to people that have really done some very challenging work, that have really pushed the boundaries not in terms of what they're saying they could theoretically do with the thing that they're making, but in terms of what they've actually done, in terms of the actual value that they've provided for the customer. So look at that. If somebody makes most of their money from actually making something that end consumers value, they've made great software that the end consumers really love, and that's how they make their money, I'd be more inclined to trust them than I would be to trust somebody that's saying, use the principles of solid and have clean code, whatever that means, to make your project. Well, look at that guy. What has he done other than making books, right? And I'm not necessarily saying that is the case or isn't the case with the specific person I'm thinking of. But what I am saying is those kinds of claims warrant a further investigation. And the more that you look at what people are saying, the more that it's rooted in hardware, I think the closer to the truth that it's going to be. And that's kind of why I encourage that skepticism, because it is going to lead you to what I think is a more satisfying way to make games and apps. And I think that if in general we start to, as an industry, have more of an appreciation for people that take a hard scientific stance towards the kinds of claims that they're making, if we really put people's claims to the test, then I think we're going to end up in a much better place. So I'll just leave you with that. Thanks, folks.